Hey there, we're still working on our first standard for Unit 8, and that is to determine solutions for polynomial equations and inequalities. We're going to be working with something called the remainder theorem, and we're going to be determining if some value that I'm just going to call k, determining if it is a zero. So let's go ahead and get started. All right, so this is the remainder theorem, and we're using synthetic division to to process through the remainder theorem. So I am going to ask us to find f of k. So find f of a given value using synthetic division, and then we're going to be looking at it in the remainder theorem as our goal. So here's our function, and the first thing we're going to do is we're going to find f of k the very traditional way, and that is by direct substitution. So I'm asking us to find f of -2, which means just substitute in -2 for x to find the outcome, to find the y value. In other words, x is -2, what is y? Let's go ahead and do that. So you're going to go ahead and substitute in -2 to the 5th power there, and then we've got 6 times a -2 and we're squaring it, plus 3 times a -2, and then minus 11. Now, the thing is that there's a lot of room for error, because not only am I raising this to the 5th power and I'm squaring it and I'm combining all of this together to get a single value, I'm also using a negative, so I have to remember my parentheses, and there's a lot of places for error. But go ahead and grab your graphing calculator or whatever calculator and determine f of -2. So pause the video and find the result, and then unpause when you're ready. All right, so I got f of -2 to equal 71. All right, now we're going to find f of k using synthetic division and the remainder theorem. The idea is that when you use synthetic division with k as the outside number, that your remainder is actually f of k. So that's what we're going to be doing. We're going to be substituting in the -2 and dividing it through, and the outcome of this is going to be 71. If we did this accurately. All right, so let's go ahead and try it. So I'm going to substitute in the coefficients. So I've got a -2. I've also going to have to make sure that I put in the 2 wholes up here that we're missing, and that's for the 4th power and the 3rd power, and then 6 and 3 and -11. Let's go ahead. Remember here we're just adding down, and then I get a 4 when I multiply, and then a 4 times -2 times a 4 is a -8. We add that one. Now we multiply again, and I get 22. -2 times 22 is -44, so that's -41. -41 times 2 is +82, and when I add -11 and +82, I get 71. So we can use synthetic division as another way of doing substitution. That is that when I use the k value, the remainder is f of k. It is the substitution done for us using synthetic division. All right, so the next thing we're going to have here are factors versus roots. What are the difference, so that we're using a common language? And that's really important as we communicate to each other. And as you prepare for, if you're taking an AP calculus class eventually, you're going to want to know what they're asking for, but you also, in your explanations, want to use the most accurate language. So here we go. A factor is a polynomial. For example, a factor could be x plus 4. A factor could also be something like x squared plus 9. These are both factors. They're factors of something that if you multiplied it, you'd get a bigger polynomial. These are factors. A factor divides in evenly and has no remainder. So if we say that 4 is a factor of 24, we know that 4 goes in evenly to 24. Well, we can also say, I'm going to use a very simple one, x minus 2 is a factor of x squared minus 4. We know that it goes in evenly and that the outcome is another polynomial. There's no extra strange remainder. And it can be used to write larger polynomials into these smaller pieces. In other words, we can basically break it down into small pieces. It still represents the entire larger polynomial. All right, a root. A root is a number. It's just a number, okay? Now, these numbers could be real. So we could have, I could have a root of x equals -3. I could also have a root of 2 plus I, right? These are numbers, complex, real, or imaginary. Other names for roots are zeros or intercepts. Now we know that when I have an x equals an imaginary number or a complex number, that it is not an intercept. It is still considered a root and it is still considered a zero. It's not an x-intercept because we can't graph it on the x-axis. All right. Why are they called roots or zeros or intercepts? Because they occur when the y-coordinate equals 0. So that means that when f of 0, which we call the remainder, now we just talked about that f of 0 when f of the k value equals 0, so when the remainder equals 0, it is a root. When the remainder equals 0, it's a root. Okay. All right, so factors of polynomials. We're going to decide if x plus 2 is a factor. So what we're going to look for is f of -2 equal to 0. That's the question. In other words, is the remainder equal to 0? Is the remainder 0? And this is how we're going to do it. We're going to use that synthetic division. So I've got the -2 on the outside. I put in my coefficients, and then we continue the process of synthetic division. I have 5, that gives me a -10. That gives me a -24. This gives me a +48, and I get 58. So I could say that x plus 2 is not a factor of 5x squared minus 14x plus 10. That's a very complete answer. And this is my evidence of that because f of -2 equals 58. I want you to think about what that means on a graph. That means the coordinate -2, 58. So there's no way that this could possibly be a 0. This is no way that this could be on the x-axis because it is the ordered pair -2, 58. So absolutely no way is x plus 2 a factor. All right, second one. I got in the way there. Is x minus 1 a factor of 2x cubed minus 3x squared minus 5x plus 6? Once again, we're looking for is f of 1, okay, equal to 0. Now remember, the reason I'm doing that is because x minus 1 equals 0 gives me x equals 1. So we're checking on whether or not there is an intercept. So is there an intercept at x equals 1? That's what we're questioning. Is the remainder equal to 0? Oops, I forgot the ER. Is the remainder equal to 0? So let's go for it. So I put in the 1. And I have 2, -3, -5, and 6. Let's give it a whirl. We drop it down, we get a 2, we multiply, we add, we multiply, we add, we multiply, we add. And the answer is yes, x minus 1 is a factor of that polynomial, which would mean that x equals 1 is an x-intercept, 1, 0. We have an intercept here. We have a factor here. All right, great job.